we have a semicircle. What we want to do is the following. Let's say here we have a rectangle which is inscribed in the semicircle. That means that the rectangle will be something like this. Could be like that. Could be like that. And so on. So as you can see, part of the diameter makes up the base of our rectangle. So what we want to do, we want to find the rectangle with the maximum area. So how can we do it? So let's start labeling this, let's say the base and the height of the, let's call this part C, which will be half of the base. Then we will have H, the height of the rectangle. So the area will be 2 times C times H. Then we can also say that the radius of the circle is, let's say, radius is 8, and say 8 centimeters. All right. Then we can say we want to find the maximum area of all the rectangles inscribed in the semicircle. That means we have to build a function. So let's start. If we just write the area as 2 times C times H, as you can see, we don't know C and we don't know H, so we cannot solve it. So that means we have to find some connection, like a relationship between C and H, so that we can write one as a function of the other. How can we do it? We also know that C squared plus H squared is equal to 8. So from here we can say that H is equal to 8 minus C squared, and we have to square root it. Alright, then we can say that the area is equal to 2 times C times H. Now we can express H as a function of C, which means square root of 8 minus C squared. As you can see now, we only have one variable, which is C. So how can we find the maximum, the rectangle with the maximum area? This is simply a function of C. We can say that A is a function of C. So that means if we want to find the maximum, we have to take the derivative of A. So let's try to do it. So first we derive this part, which gives us 2 times this part here. 2 square root of 8 minus C squared plus, then we have to take this part, 2 times C, times now the derivative of this part here. As you know, or as you should know, the square root is the same as having an exponent half here, That would mean we take the exponent down, in front, half. Then we have to take 8 minus c squared. This was half minus 1, which becomes minus half. And then we have to take the derivative of what is inside here, times minus 8, derivative of 8 is 0, so we only have the derivative of minus c squared, which is minus 2c. Okay, let's see what we can do at this point. We can make some simplifications. These two can cancel out with these two. So we have, here we have 2 square root of 8 minus c squared plus c. This exponent here is like taking the whole thing, denominator, which is 1 over 8 minus c squared. And then we have to change the sign of the exponent, half, times minus 2c. So this is the derivative. What we want to do, now we want to set the derivative to 0. Why is that? To find, if you have a function, you want to find maxima or minima, you have to set the derivative to 0. Okay, so let's first find the common denominator. Common denominator will be 8 minus c squared to this power, which will be a square root. So that means that here we have to multiply 2 times 8 minus c squared. We have to multiply by itself, because this denominator will be the same as saying times square root of 8 minus c squared. So this is the first part, plus c minus 2c. So this becomes, let's leave it like this for the time being. Alright. So let's see what we can do at this point. So this derivative, 8 is the radius. C will always be less than 8, more than 8. That means that this part will always be positive. Since we want to find the derivative where the derivative is 0, we can just forget about the denominator. So that means, let's now look at the numerator only. Numerator is 2 times 8 minus c squared minus 2 times c squared. Okay, we want to set it to 0. We want this to be 0. Let's do like this. Okay. So that means that 16 minus 2c squared minus 2c squared, so minus 4c squared is must be equal to 0. Then what can we do from here? We can say 4 times 4 minus c squared equal to 0, which means that gives us c squared. C will be equal to plus or minus 2. So we are dealing with length, so that means that we only take the positive, so that C is equal to C will be 2. Alright, so let's see what is then the value of H. We had that H was, we had the C squared plus H squared was equal to 8. Okay, now we have H squared will be equal to 8 minus C squared, which is 4, equal to 4, which means that H, again we only take the positive, H is equal to 2. Alright, so that means that the rectangle with the largest area is the rectangle which has base, which is 2 plus 2, which is 4, and the height, which is also 2. So this will be the rectangle with maximum area. So let's go back here to the... So this also tells us something interesting, that what if instead of taking the semicircle, we take the whole circle? What would be the rectangle with the largest area? That will be the following. There will be a square which side, this will be 2, this will also be 2, and the height will also be 2. So the base will be 4 in total, the height will be also 4. For the whole, if you take the rectangle inside the whole circle. If you only take the semicircle, it will be 4 and 2. Alright, so I hope this is clear. This is how to solve this kind of problems. So just remember, you can just forget about the denominator because it's always positive and it's never 0 basically. Even if it was negative, you could, in this case, you have a root, so you have to be careful. But in general, as long as the denominator is not 0, if you just want to find maximum or minimum of a function, you can always leave the denominator out. Alright, if you have any questions, just leave, you can just leave a comment.